Now, let's start exactly from where we stop. We are done with identification of mirror. I told you concave is having the reflecting part inside and is having the silver part outside. And I told you that convex is having its own reflecting part outside and is having the silver part inside. That's how we identify them. And in the diagram, this is how you see. This part is the reflecting part. Sorry, is the silver part. While inside is the reflecting part. So this is concave. Now here, you can see that outside look like the reflecting part, while inside look like what? Silver part. This is what? Convex. Now, let's go to tanks used in mirror. Like we have some tanks used in lens, we also have tanks used in what? Mirror. They almost look alike. The first tank in mirror is called aperture. The aperture of the mirror. The aperture is the same thing as the width. That's width. The width of the what? Mirror. Some people call it the breadth of the mirror. Some people call it the length of the mirror. So the aperture is the width of the mirror. So that is aperture. So for example, define the aperture of the mirror, you say this is the width of the mirror, meaning from here to here. From here down to here is called the aperture. So from here down to this place is called the aperture of the mirror. So we also talk about the pole. The pole. The pole is just like a optical center in the lens. That's the middle. A part of the lens where light does not what? Deviate is called optical center. Here too, the pole of the mirror is just the center of the mirror. It's represented with what? Capital letter what? P. That is the pole of the mirror. Pole of the mirror. So you can see I am putting P at the what? At the middle. So that's another things we use in the lens. Then we also talk about principal focus. Principal focus. We discuss the same thing in lens. Principal focus. As a point, I'm revising lens now. Principal focus on the lens is a point where parallel rays meet, which is converge, or from where the what? Diverge. That is what you call principal focus. Now here too, let's look. You can see these are parallel rays. So when they hit by the mirror, then they reflect and meet at this point. So this point where the reflection of them, after the reflection means sending them back. So the ray is coming like that and they were sent back. This one too is coming like that, like this, and it was also what? Sent back. So both of them meet at this point. A point where both of them meet or converge after the reflection by the mirror is called what? Principal focus. If it is in a concave mirror, we have it here. If it is in a convex mirror, we have it here. Then we also talk about focal length. Focal length of the mirror. Focal length. I think we already understand what focal length is. Focal length in the lens is the distance between the optical center and principal focus. That is for lens. Now here, focal length is going to be the distance between the optical center and the what? And the pole. So this is focal length now. Distance from the principal focus and the what? And the pole. That is what we call optical center. Then we have center of curvature. Center of curvature. We use capital letter C. So this one is small letter F, capital letter F, then capital letter P. Then we have this one as capital letter C. Center of curvature. How do we go by center of curvature? Center of curvature is of any mirror is the center from which is the center of the sphere. Center of the sphere from which the mirror form apart. Center of the sphere from which the mirror form what apart. What do I mean? For instance, we use this to form a circle. It becomes a what? Sphere. So the center of that sphere, if here is the center of the sphere, then that place is called center of what? Curvature. So this is the center of the sphere from which the mirror form apart. is called center of what? Curvature. So then we also talk about the relationship between focal length and radius of curvature. Radius of curvature has been discussed under this. So there is a relationship between f, that is focal length, and r, radius of what? Curvature. So which means anytime you need focal length f, we can always use radius of curvature divided by 2. So when you need focal length in any question and you are not given, and you are given radius of curvature, just divide that radius of curvature by 2. That will be the answer to what? Focal length. So that's the relationship between focal length and radius of what? Curvature. So these are the little what's it called? Little terms I can discuss. I discuss aperture as the breadth or the width of the mirror. I discuss the pole as the center of the mirror. I discuss the principal focus as the point where the reflected rays converge, or from where the reflected ray diverge. Then I discuss the focal length as the distance between that of the pole and the focal length. Then I discuss the center of curvature as the point of the sphere from where the mirror forms apart. Meaning when you use the mirror in forming a sphere, pick the center of that sphere, that is the same thing as the center of curvature, and it is denoted with capital letter T. Then we also notice that there is always a relationship between this small f, focal length, and that radius of what? Curvature. So, and that is the relationship on the board. F is equal to R over T. Now, application of mirrors. I'm talking about application of curved mirror now. When I say application of mirror, I'm talking about curved mirror. I have two types of mirror on the board. So I have concave and I have what? Convex. This one can be used in shaving. So shaving mirror is an example of what? Concave mirror. This one can also be used in other optical instruments like microscope, telescope. So the mirror there are all concave. Then this one can be used as a driving mirror. So the major application of convex lens is it is used as what? Driving mirror. Why are we using this one as a concave? It will always give a very enlarged, a very erect, and a very virtual image. The image is going to be more bigger, especially when you put yourself between very close to it, because the more closer to the mirror you are, the more bigger the image is. So that is why we always use this one as shaving mirror, so that it can bring an enlargement in our face, and it's going to be erect and it's going to be virtual because you cannot what? Catch it. Then it is also used in all other optical instruments like microscope, telescope, and so on and what, so forth. And it is also used as a spherical mirror. There's something we call spherical mirror, which is a particular part, a particular type of mirror, a particular type of concave mirror is called spherical mirror. A particular type of a concave mirror is called spherical mirror. So we call it parabolic mirror, yes. So concave is also used in forming a parabolic mirror. So parabolic mirror is not an example, it's not a type under mirror, it's just an example of what? Concave. And those are the mirrors they use in the headlamp. So those are the mirrors they use in headlamp. Those are the mirrors they use by the hunter. The hunters, when they want to hunt at night, they put a particular light on their head like this. That light carries some mirrors, and the example of that mirror is what? Concave. We call it headlamp. So those are the major three applications of concave mirror we have. And this one is mostly used in driving mirror. Why? Because it can give a very wide range. Meaning it can pick an object even when the object is very, very far. But the disadvantage of this one is that it's always very diminished. It can give wrong impression about the distance of the object, and the object is always very what? Diminished. So we continue in our next class. Thank you very much.